What's up, guys? Yeah, so today let's quickly give the very short introduction for these rotation matrices. Okay, so let's just consider this called P of t, which is a rotation matrices, cosine t minus sine t, sine t, cosine t, and the idea is that somebody gives you a point, let's say x and y. And if you apply this PT on this X and Y, they will give you the rotation that with the same length, but with the angle T. Okay. Okay. And we want to claim that this is exactly happens. Okay. So basically, we want to prove the following three things. The first thing is that this PT times P of S will be T plus S. Okay, and the second thing is that this PT to the n will be PNT. And the third one is the PT inverse will be this PT inverse will be P minus T. Okay, and remember P of T is cosine T, sine T, negative sine T, cosine T. Okay, so simply let's quickly prove it. Okay, so let's first check that 1 implies 2. Okay, so for 1 implies 2, let's try to prove. Let's see. Okay, so let's suppose 1 is correct, and we want to prove that 2 is correct. So the idea is that we can prove by induction, right? So I can check for n equals to 2, right? That bt equals to p2t. So this is by 1. Okay, and by induction, I assume that n equals k is correct. So pt to the k will be pkt. Then let's consider n equals to k plus 1, which is pt k plus 1, which is pt k bt, which is pkt bt. This is the induction step, which is bk plus 1t. Okay, so finish the induction step. Okay, and the third one that one can easily prove by 1, because I can use pt p negative t equals to p0, which is identity. So p negative t inverse, pt inverse will be p negative t. Okay, so remaining is only the first one. So let's give the proof. Okay, so this is the final results. Okay, so we need to prove that this is cosine t, sine t, and we need to prove that this is indeed the rotation matrices. So we need to prove pt ps equals to pt plus s. Okay, so one maybe more advanced idea is that you can map exponential it to this cosine t sine t, and you can check that this is a group homomorphism. So basically, you can see that this pt t belongs to 0 to pi is isomorphic as a homomorphism is basically u1. Okay, but let's forget about this one. Just do the simple computation. So let's do PTPS will be cosine t, sine t, negative sine t, cosine t, and the cosine s, sine s, negative sine s, cosine s. Okay. Now let's just do the matrix multiplication. So this guy will be cosine t, cosine s, minus sine t, sine s, and this will be negative cosine t, sine s, negative sine t, cosine s, and the which will be sine t, cosine s, plus cosine t, sine s. This will be negative sine t, sine s, plus cosine s, cosine t. Okay, and notice that this guy will be cosine t plus s, sine t plus s, negative sine t plus s. Just use the standard trigonometric in identity. Okay, so which proof this is exactly pt plus s. Okay, so this is the property of rotation matrices. See you guys next videos.